Well, question number 3 says a cyclist is riding along a straight horizontal road. The total mass of the cyclist and his bicycle is 90 kg. The power exerted by the cyclist is 250 watt. At an instant when the cyclist speed is 5 meter per second, his acceleration is zero point 0.1 meter per second square. Find the value of the constant resistance to motion acting on the cyclist. Well, it's one of the most common and simplest solution, and we know that in such case we apply the concept of the motion law to find our result. So let's start the solution applying the motion law of Newton. And cyclist is riding horizontally forward, so it is horizontal direction. And the concept we have already picked up is the driving force minus resistance force is equal to mass into acceleration. Well, so driving force is, the formula for driving force is power over velocity. Power over velocity. Then the resistance to motion. Remember, weight should not be ignored. Weight causes resistance to motion either as driving force or resistance force. We are supposing here resistance force. Okay. So as the weight, the horizontal component of weight is mg sine 0 degree. Why is 0 degree? Look at this. He is moving along a straight horizontal road. So in terms of triangle, horizontal road and the vertical line of the triangle are the same axis, same line. That's why angle is 0. Then there is a constant resistance to motion. That means the heel is not smooth at all, which is to be obtained. So resistance to motion, and mass of the particle is given 90 kg. 90, acceleration is given 0.1 meter per second. Now let's substitute the values we do have. Power is given 250 watt, so 250, and velocity is also given as 5 meter per second. It is 5. Since the angle is 0 degree, sine 0 is 0, so there remains resistance force is equal to 90 into 0.1, that is nothing but 9. So it is going to be frictional force is equal to 250 over 5 means 50 minus 9. Hence our frictional force constant resistance to motion is 41 Newton. 41 Newton. That is what the final answer. Let's move on to the next question. Immediate next question says that the cyclist comes to rest, come to the bottom of a hill inclined at 2 degree to the horizontal. So he is no more riding on a horizontal road. It is inclined at 2 degree to the horizontal. Well, given that the power and resistance to motion are unchanged, find the steady speed which the cyclist could maintain when riding up the hill. So for this, first of all, we will draw a diagram. Okay, let me draw the diagram. Suppose this is horizontal line and the heel is inclined at 2 degree here, and the cyclist is over here. Okay, he is moving upward along the hill. Then the normal reaction will act like this. This is normal reaction, and weight is trying to pull him downward, vertically downward. Okay, well, so that's what our triangle is. Let me erase this unnecessary part. And how much is the angle at which the heel is inclined? It is 2 degree. 2 degree. At 2 degree angle the heel is inclined. Okay, well, now we have already drawn the diagram. Let's solve the question. We are going to apply the same concept as we did in the previous case. That means concept of the motion law of Newton. So let's write that now his direction is he is moving up, so it is the direction. The concept is driving force minus resistance force is equal to mass into acceleration. Well, let's see how much is the driving force. They have told that driving force is P over V minus resistance force should remain unchanged. Look at this, they have written here uh, power and resistance to motion are unchanged. How much was the power? Power was 250. Power was 250 watt and resistance to motion is 41 Newton. So we can substitute the same values. Yes, resistance is 41 Newton equal to mass into acceleration. Let's see whether there is any acceleration or not. They have told he is moving at a steady speed. So there is no acceleration, means it's 0. Power we have seen it is 250 and velocity is to be obtained. Let it be V. Wait, we have skipped something which is weight. We didn't calculate weight. Weight must cause the resistance to motion because he is moving up and weight is trying to move him down, so it is definitely resistance to motion. So what is the horizontal look at this, he is moving up, this is his direction, so this is vertical direction in terms of this triangle. So for vertical component we use mg sine, what is the angle? 2 degree, equal to, there is no acceleration, so right side is 0. Well, minus 41, mass of the cyclist is 90, acceleration due to gravity is 10, and sine 12, sine 12 2 degree equal to 0, equal to 0, or 250. Now here also we made a mistake, it is not 4 into, it should be 41 plus, sorry, it will be 41 plus, so 41 plus, not plus, that is negative, sorry, it is negative. Okay, so what is it going to be? Ultimately 250 over velocity is to be obtained, okay, V, and if we transpose everything on the right side, it is going to be 41 plus 90 into 10 means 900 sine 2, 900 sine 2. Well, hence our velocity is going to be, let it be the last of all steps, as we don't have more space to write, we should not extend this any longer, is equal to 250 over 41 plus 900 sine 2, sine 2 degree. Let us use our calculator. If we use our calculator, it is going to be, yes, 250 divided by 41 plus 945, 3.45 equal to 3.45 is the velocity which is positive, so he is moving upward. This is what the final answer is. So that's all about the solution to question number 2, and there is nothing complicated in this one. So let's move on to the immediate next question. The next question says, yes, so that is what the next question is. It is number 4, which says the diagram shows two particles A and B of masses 0.2 kg and 0.1 kg respectively. The particles are suspended below a horizontal ceiling by two strings AP and BQ attached to fixed points P and Q on the ceiling. The particles are connected by a horizontal string AB. Angle APQ is equal to 45 degree and BQP is equal to theta degree. Each string is light and inextensible. The particles are in equilibrium. Find the value of the tension in the string AB. Well, first of all, before starting our solution, we should complete the diagram using our right angle triangle. Let's complete the diagram. Here we can join this. After that we can join this. Okay, so for this one, this is the onward force, that means positive, and here this is negative direction of x-axis. Okay, so angle may remain as it is. Let us erase these unnecessary parts. Yes, this is our figure is. Well, so now let us go back. What did they tell us to find? The question told us to find the value of the tension in the string AB. Okay, AB is this portion. This portion is to be obtained. Before that, we will use the first triangle. Okay, and what is the concept we are going to apply? Very simple. The concept is the most widely used concept of motion law of Newton, and the motion law of Newton is known to us. It is as this is. We are going to use the first particle, the first triangle. Let us resolve the vertical forces. Let us find the resultant force which is acting vertically. So vertical direction, this is vertical direction, and vertically for this one, what is the driving force? The concept is driving force minus resistance force is equal to 0, because the system is in equilibrium, so there is no acceleration at all. Right side is 0. Now let's see, a driving force means upward force. What is the upward force? For the first triangle, this is our first triangle. Okay, this one is our first triangle. Okay, for this one, what is the upward force? Upward force is this one. We can suppose it to be the direction. So how can we find the component of force along this? This is nothing but mg. Let me change the color of the stylus. Yes, this is mg. I mean, sorry, not mg. It is this one. Tension is over here. Let me change the ink. So in terms of this tension, this is the hypotenuse. It is tension in, yes, tension in AB, not AB, AP. Tension in AP. Then as we are resolving the horizon, I mean vertical component of this tension, so it is sine 45 degrees. Sine 45 degree minus resistance to motion is this one. Okay, so this one is, sorry, we are not resolving the horizontal forces, we are resolving the vertical forces. So what is the negative force? Negative force means which is downward. It is mg cos 0 degree. If you dissolve it It will be either cos 0 degree or sin 90 degree, whatever you tell, it will be all the same. So negative force vertically which is causing resistance to this motion is mg cos 0 degree, equal to right side is 0. After that, if we substitute the values, tension in AP, then sine 45 is what? 1 over root over 2. So it is going to be, so let us write together 1 over, it is tension in AP over sine 45 is 1 over root over 2, minus mass of the particle is 0.2 kg. 0.2, acceleration due to gravity is 10 and cos 0 is 1, equal to 0. So tension in, we can write here for AB, we are writing for, let us write here for which string are we using for AP, for AP, tension AP. Well, then tension in AP over root over 2 is equal to, if we multiply 0.2 by 10, it is nothing but 2. So tension acting in the string AP is actually 2 square root over 2. Well, so this is one of the tensions has been obtained, but they didn't tell us to find tension in AP. They have told us to find tension in the string AB. Now for AB, we will write here for AB, for AB. Let's see how is AB. AB is actually horizontal string. Look at this. This is AB. This is horizontal line. So for, if we use this triangle, if we use the same triangle, I mean first triangle, then it is, the concept will remain same actually. We are going to apply the same concept for the horizontal string. So it is horizontal movement. So driving force minus resistance force is equal to mass into acceleration. Okay, what is the driving force? Let us see. For this triangle, for the first triangle, what is the driving force? Driving force is this one, tension in the string AB. Okay, and resistance force is this portion. Okay, this portion. Well, so driving force is, our driving force is going to be what? Tension in string AB minus resistance to motion is the left part as I have shown, which is tension in AP cos 45 degree. Okay, because we are resolving the forces horizontally, we are finding the resultant force acting horizontally, and the right side must be 0 because there is no acceleration at all. The system is in equilibrium. Okay, then tension in AB minus, or we can write equal to, tension in AP has already been obtained, which is how much? 2 square root over 2. So 2 square root over 2, and cos 45 is 1 over square root over 2. Hence tension in, we can write over here, hence, no, let us continue writing just below this. Hence tension in AB is equal to, if we dissolve the square roots on the right side, it is going to be 2 Newton. 2 Newton. So this is the answer to the first part of this question. They have told us to find the tension acting in the string AB, which is 2 Newton. Well, I think you have understood. First we have found the resultant force vertically, resolving the forces vertically, then we have resolved the forces horizontally. Finally, we have got that the tension acting in the string AB is 2 Newton. Well, now let's move on to the next question. Next part of the question. The next question says, find the value of theta and the tension in the string BQ. So this is, we are going to apply the second part of the, second string or third string, whatever, for BQ. And the same concept we are going to apply for finding the tension in BQ also, and we will resolve the forces horizontally, which is the concept is as it was, it must be same. Driving force minus resistance force is equal to MA. Now for the triangle which contains BQ, let us see what are the forces over here. Look, if we include BQ is over here, and we are resolving the forces horizontally. So for horizontally, what is the driving force? Driving force is this, using this string BQ. Okay, tension in BQ, then cos theta. Tension in BQ, cos theta. Okay, and negative force is what? Negative one is in this case for the triangle, this triangle. For this triangle, negative force, horizontal negative force is this part. Let me erase this first. Sorry, this is going to be erased. Yes. Now negative direction is, as this is positive direction, this is now positive direction for the string BQ, and tension in AB is now acting as negative direction. So for driving force, it is going to be tension in BQ cos theta, and negative force is nothing but tension in AB. So let us just write that driving force is tension in BQ, or tension in BQ cos theta for horizontal axis, cos theta, minus resistance force is nothing but tension in AB, as I have shown, equal to mass into acceleration is 0, because the system is still in equilibrium state. So if we dissolve this, it is going to be tension in BQ cos theta is equal to, tension in AB is already we have obtained, it was 2 Newton 2. So cos theta is equal to, cos theta equal to 2 over tension in BQ. Tension in BQ, in the string BQ. Okay. We may leave this as equation number 1. Well, for the equation number 2, let us change the ink. It is going to be, for BQ, the same tension or same string has been used, but we will resolve the forces vertically. Okay, let us find the vertical resultant force using the same triangle. If we analyze it, look at this is the triangle. Okay, so for vertical force, what is the driving force here? Let us write the driving force, and the concept is driving force minus resistance force is equal to mass into acceleration. Or the triangle was, if I draw the triangle vertically, then it will look like this way, this, and here angle is theta. Okay, and we are resolving the forces vertically. This is horizontal, I mean a vertical force is to be calculated. We are calculating vertical force. Let me show the vertical direction. So this is vertically upward force and this is vertically downward force. So for earth, and this is here is BQ. B is over here and here is Q. Okay, so vertical and the particle, the mass of the particle is 0.1 kg. 0.1 kg. So if we resolve the forces vertically, what is it going to be? Tension in BQ. So vertical direction, it is going to be sine theta. Sine theta minus resistance forces just mg sine, sorry, sine 90 or cos 0, whatever you tell, mg cos 0, or let us write sine 90. Okay, so that you can understand better. Sine 90 degree equal to, there is no acceleration at all, that's why it's 0. Well, then tension in BQ, if we isolate tension in BQ, tension in the string BQ, sine theta equal to mass of the particle is 0.1. So 0.1 into acceleration due to gravity is 10. Then sine 90 is 1. Okay. Or sine theta is equal to, if we isolate sine theta, it is going to be 0.1 into 10, that is 1. 1 over tension in BQ. BQ. We may leave this as equation number 1. Equation number 2. Okay. Now from solving this equation simultaneously, we can write here from equation 1 and 2. Equation 1 or equation 2, well, let me change the ink again. So equation 2 over equation 1. If we divide equation 2 by 1, what is it going to be? Equation 2 is sine theta. So it is going to be sine theta over cos theta equal to, the right side of the second equation was 1 over tension in the string BQ over 2 over, the first equation was 2 over tension in the string BQ. Tension in the string BQ. So if we dissolve this, look at this, both of the denominators are tension in BQ, so they can dissolve each other. And on the left side, sine theta over cos theta, it is tan theta. Tan theta is equal to 1 over 2. If tension in BQ dissolve each other, 1 over 2. Hence our tension is going to be, I mean theta is going to be tan inverse of half or 0.5, whatever you tell. So let us see the value of tension, value of theta. If we divide, let us use our calculator to get this. So our calculator is over here. Tan inverse of, tan inverse of, so let us write that theta is equal to, hence our theta angle is 26.6 degree. This is the value of theta, but it is not the final answer. They have told us to find the theta, value of theta as well as the tension in the string BQ. So the final part is left to be found. So we can write tension, hence tension in the string BQ. Let us see, from any of the equation we are going to pick up the information. Tension in BQ is actually 2 over cos theta. 2 over cos theta. Okay. So cos theta is equal to 2 over cos theta. Let us use the calculator again. 2 over 2 point 2.24 Newton is the tension acting in the string BQ. And I think you have got my point. It is not difficult or complicated at all. Simply we have applied the concept of the motion law of Newton frequently. Okay. So this is what the solution to question number part B of question number 4, and it was the first part of the question. 4 times in total in among these two solutions we have applied the same concept of motion law of Newton. 4 times we did apply them. That means we have found the resultant forces acting horizontally and vertically. That's what they have told us to find. And finally we have obtained in question number 1, we have obtained the tension in the string AB. And then in question number B, we found in the solution number B, we have found the angle between the string and the ceiling, which was theta, and it was actually 26.6. And the tension in the string BQ was 2.24 Newton acting on this. So, and let me show the first question. I mean, question number 3. Question number 3 was very similar. Also, we have used the concept of the motion law of Newton. And thank you all for being with me to watch this video. May Allah bless us all with the beneficial knowledges and wisdoms. Fi amanillah.